Okay, hello everyone. One second. Okay, hello everyone, and welcome to Concordia University's Fourth Space, and thank you for joining us for today's event, the AACEI 3+1 Construction Elevator Pitch Competition. Now, to help situate you, we are streaming to YouTube live from Fourth Space, and we are located here on unceded Indigenous lands in Tiohtià:ke, Montreal. And at Fourth Space, we work with our university community to help mobilize knowledge, co-create daily activities that examine research questions, projects, things in development across the university. And we're running today's event as a live stream Zoom meeting. And if there are any questions from anyone attending in the audience, we ask you just to enter those into the chat, and we'll collect all of those and get them to the presenters after the fact. And for everyone else in the space, if we wish to communicate, just give us a signal and we'll get a microphone to you so that people on Zoom can hear that way. Okay, with that, it's very much the plan to pass things over to Dana Shamsulahi from the organizing committee. Dana, welcome.
Hello, everyone. Welcome to AACEI 3+1 Construction Elevator Pitch Competition. This is Dana Shamsulahi, President of AACEI Montreal Section Student Committee. Thank you all for joining to this event, either in person, in Fourth Space, or online through the Zoom platform. Before we begin, I would like to invite Dr. Mazdak to share his insights with the audience.
Thank you very much, Dana. You were supposed to speak 2 sentences. I counted it was 5. Mazdak Nikmacht, welcome to the 6th event since round of 3MT+1 or construction elevator pitch. I'm going to give a very, very quick history, and there are a few people that I have to thank. This is the 6th round, as I mentioned. We first pitched this idea to AACEI Montreal board in 2017. And when we were revamping the student chapter here at Concordia, I want to thank Liz as the representative of the Montreal board for being generous and trusting in us, believing in us, and supporting this event. Every year it grew bigger and bigger and better and better. The first round was in 2018, and like I said, it's the 6th round now. We changed the name last year from 3 minutes to construction elevator pitch because of copyright of the name, of course. And I wanted to thank the students who made this happen, particularly the ones who are not here anymore. They're not the students. Now they are like big names in C-suites. Starting with Alex, and then Mo, and then Hassan. The 3 of them were instrumental for making this event happen and the event being what it is today. And the newest member who really helped us this year is Dr. John Wang Ma, one of the newest member of our construction engineering group. I'm going to ask him to join us and introduce this year's event. So with that, I pass it to John, and I hope you enjoy the event.
Thank you for your kind introduction, Dr. Nikbat. Hello, everyone. I'm John Wan, so assistant professor in the BCE department in Concordia within Construction Engineering Management Group. And today, I just wanted to echo to thank everyone again, and especially our sponsors from Hatch and Turner and Townsend and Rive and also AACE, and also our judges today. So Roxanne from Turner and Townsend, and Chris from Rive, and Satyafo from Hatch, and Dr. Shayan Shayeteh from Concordia University. And also thanks to everyone here offline and then online. And lastly, for the AACEI, the Montreal chapter, student committee members. And to briefly introduce about today's event, we had over 20 applicants, abstracts, and then it was really hard to narrow down the number to 8 for the 4-minute presenters today. And for the process, so we have 4 judges, as I mentioned. So they will make a decision based on 4 criteria, for example, like presentation quality and the level of detail of the presentation and so on. And then after then, we will find out like the final 3 applicants for the prizes. And let's see how it goes. And please, everyone, enjoy today's event. Thank you so much.
Thank you, Dr. Ma. It's so exciting. It's so exciting to see professionals from academia and industry, as well as students, all gathered here today for this event. This event is organized by AACEI Montreal Section and Concordia University. I would like to thank everyone who helped us in organizing this event, especially Dr. Moselhi, Dr. Nikbacht, and Dr. Ma from Concordia University, and Mr. Hajir Emrani and Mr. Les Macmullen from AACEI Montreal Section. Today marks our 6th annual thesis competition, and we are proud to be able to host it today with all of you at this wonderful place. I would like to introduce AACEI student committee members who generously volunteered to expand this event and enhance the connection between academia and industry. Abdelhadi Omar, our financial director. Araham Martinez, planning and logistics director. Shuruk Garib, Public Relations Director, and Amr Alam, Operational Director. This year, we also had volunteers that really helped us, Azad Sufipur and Delaram Sadeghi, Jidobi Obifuna, and Kimia Khalili and Moaz El Kabalawi. This year, this year's sponsors are AACEI Montreal Section, Hatch, Turner and Townsend, and Rivet. We are grateful for all of their generous support. Now it's time to welcome our honored judges, Dr. Shahin Karimi, Senior Lecturer from Concordia University, Ms. Safia Mega, Regional Manager, Project Controls and Estimating at Hatch, Ms. Roxanne Joubert, Associate Director from Turner and Townsend, and Mr. Christophe Guiden, Senior Consultant from Rivet. This year, we also have special guests from academia. We have Dr. Hamad here, and also from industry, including Mr. Pensa from McGill Construction, Ms. Klasinskas from Rivet, Mr. Salami from Hydro-Quebec, Mr. Shaban from Turner and Townsend, and Mr. Loic Rennie from Hatch. Before starting the thesis competition, I would like to congratulate Dr. Osama Moselhi, Professor and Director of CCM at Concordia University, for his appointment to the Order of Canada, for his groundbreaking contributions to the field of construction engineering and management. I would like to invite Dr. Moselhi to share his insights with the audience.
Thank you very much, Dina, and thank you all very much. This event was celebrated, and maybe this is the second time or third time here at Concordia. In any case, I just wanted to share a few things with you. While I'm happy, honored, but at the same time very humbled by that honor. And I attribute that to many contributions of talented people along the journey of my life. Students, some of them former students, maybe some of them could be here. Current students, some of them are here. My colleagues, and a number of them you've already seen, Dr. Nikbat, Dr. Hamad, Dr. Ma, and many others indeed. Professors, chairs of departments, deans, senior management of this Concordia University. Indeed, there were so many opportunities along the way. Some of them really had to do with you don't design things like that. It just happened. And I share a few little things here and there, but a number of impactful meetings, meaningful decisions. One of them is this building that we're in here now. Others, even the name of our department. I don't think any faculty member will get a chance to name the department that he works in. So all of these opportunities and many others outside Concordia on the global scale, universities in the Far East, in rest of Canada, the US. But in any case, it was all the pleasure of meeting people, working with people, and really having them make a dent and a real impact on the way things happen. So to all of you, thank you all very much. And I really appreciate that. What can I say? My former student before that, he also had a beautiful event like that and prepared the gift and a lot of this stuff. So I do thank you very much from the bottom of my heart. Thank you all very much. I don't want to take much of your time. Thank you.
Hello, everyone. So before I start, of course, again, I would like to thank Dr. Salhi for all his for his beautiful words, and like it's such an honor to be working with him. So to introduce myself, as Dana said, I'm Shuruk Garib. I am the communication and the PR in the board of directors for AACEI Montreal Section Study Committee. So we are so proud this year to have received many strong abstracts from the top universities in North America, making the selections process quite challenging. Today, we've selected 8 students who developed research for the final stage of the 4-minute presentation. We've also recognized promising abstracts in their early stages and chosen another 8 for a new special segment of 1-minute video recorded presentation. Before we dive into the competition, let's go over the rules and regulations to ensure smooth transition between segments. So we have 2 presentation modalities this year. The first one is a 4-minute live presentation across divided into 2 main streams. In the first stream, under the domain of construction project management, planning and control, we have 4 participants presenting their research, while the second stream is focused on automation, digitalization, robotics and construction, also featuring 4 participants. Each contestant has 1 minute to set up and 4 minutes to present. Audience questions will be collected and screened and presented to the contestants during the Q&A session, following each theme. Please ask Kimia and Muaz, they are over there. Hello, Kimia and Muaz. For a pen and paper to write down your question, and remember to include the name of the contestant your question is addressed to, and also the topic if you can recognize. While for the 1-minute video recorded presentations, we've divided them also into 2 streams, which are the third stream, sustainability and infrastructure, and the fourth one, robotics and AI, each featuring 4 participants. After all presentations, we will have a Q&A session for all contestants with the jurors. Audience questions will be included if time allows. We will then proceed to vote for the 1-minute contestants. After the voting, we will take a short break for judges to decide the winners of the 4-minute presentations and for the audience to choose the 1-minute winners. Please note that there is a maximum time allowance of 4 minutes for each presentation. If you exceed this by more than 10 seconds, we will have to intervene. Your vote is very important to us. You have the chance to choose and select one of the 3 contestants for the second stream. We've designed a voting system for the audience that will be shared before the voting period starts, online through the chat and in person via QR code. It's now time to pass the baton to Delaram, who will moderate the upcoming session. I urge everyone to actively participate, ask questions, and engage with the presenters. Good luck for all participants, and let's enjoy this event together. Thank you so much.
Thank you, Shuruk. Hi, everyone. Welcome to the first stream of the 3+1 minute construction competition centered around construction, project management, planning, and control. I'm Delaram, and it's my great pleasure to be the moderator for this part. In the first stream, presenters will showcase their research on project management, planning, and control, critical topics across industries, particularly in the construction industry, which is known for its sensitivity to errors and slow adoption of technology worldwide. Within the construction sector, professionals often wonder which methods offer the best project leadership and control. Due to the uniqueness requirements of each project, planning and management in this field come with complex challenges. Lack of effective project management and planning during the construction process can end up costing a lot of time and money. We as engineers are committed to continuous training and staying updated on technological advancements to ensure we have the knowledge and skills necessary to tackle the challenges of our industry, which is one of the most important reasons for all of us to be here today. With all that in mind, I'd like to open the session and introduce our first presenter. But before we proceed, I would like to remind our respected jurors and also our in-person and online participants to write down their questions and also indicate the recipient of the questions to help us to properly address them. And also, please be prepared to scan the QR code at the end of the second stream to be able to vote for your favorite participants. Without any further ado, I would like to introduce our first presenter, Bae Shung. He will present his research under the topic of development of a blockchain prototype for collaborative risk assessment of construction projects. Welcome to the competition. Are you ready?
Yes, I'm ready to begin.
You have 4 minutes. Your time starts now.
All right. Construction projects can be extremely complex due to their dynamic environment, and there can be various risks throughout the project lifecycle. There are challenges related to the risks, can result in cost overruns and poor project performance, and that is why the risk management process is extremely important in the cost engineering of construction projects. Risk management goes through 5 phases, as you see in the figure: risk identification, risk assessment, risk analysis, mitigation, and monitoring. But the problem in the industry is in the way that we identify and assess these project risks. Usually, project participants will maintain a risk register to evaluate and keep track of project risks. And whether this risk register is merely an Excel spreadsheet that is being emailed around participants, or whether if it's a system that people can access through the internet, they are centralized systems with a single point of control and ownership of data. This means the system has a single point of failure, which leads to security issues and lack of transparency. As you may all know, risk-related information can be quite sensitive for whoever it is, the contractor, owner, designer, or the supplier. So we identified the need to decentralize the current risk assessment systems and the tool we decided to use was blockchain technology. For those of you who are unfamiliar, blockchain technology is a database mechanism where the information is stored in a distributed ledger, and the information will sync and update among the participants simultaneously without having a control party who has access to the database solely. So using this blockchain technology, number one, we want the risk assessment to be on a secure platform where the risk records are transparent and traceable. And two, as risk estimates can be sensitive to each party, we want to preserve the confidentiality of the inputs by using cryptographic functions. To explain the architecture of the system, blockchain networks exist in different types. The one we configured is a private permission blockchain using a platform called Hyperledger Fabric. And while we have the blockchain running in the back, there needs to be a way for the users to interact with it. So we developed a front-end user interface that is connected to the blockchain network. To demonstrate how it works, here is the overall workflow of the blockchain prototype on the right. Starting from the user interface dashboard, project owners can create a new project and multiple contracts within a project. Contract items and risk events that consist the contracts can be identified and added in the platform. Most importantly, any user in the system can now provide their individual risk assessment input for the contract items and risk events. These inputs will be aggregated on the blockchain platform, so the confidentiality is preserved. The output that combines all experts' input can be exported so that risk can be further analyzed using Monte Carlo simulations and other analysis techniques. So to summarize, we developed a blockchain-based method that enables collaborative risk assessment while preserving the confidentiality of each participant input. This process could help shift from centralized systems that has issues related to security and transparency into a decentralized one that will improve overall data quality and enhance participation from all participants. We are working on validating this prototype through case studies of actual projects, and pilot testing it on an actual project would be the final goal. Thank you for your attention, and I would be happy to answer any questions.
Thank you. Now it's time for our judges to ask their questions.
Thank you very much for the presentation. I am Shayan Shayeteh from the Concordia University. I'll ask my first question and then I'll pass it to the other panelists to start their questions. Your first question is related to the risk inputs, or basically any sort of data that you receive in order to analyze. So when you receive risk inputs or any sort of data to analyze, how does your method evaluate the data in terms of centrality or the dependency of the data or level of importance or the weight factor?
I see. So the risk assessment inputs, the way it's modeled in our system is using a 3-point estimate on the impact of how each risk has on the cost of the contract. So we're getting these 3-point estimates from each participant, and we have a weighting system that uses a fuzzy method. And we have all these criteria to weight each participant's input to aggregate them using a cryptographic function.
Okay, thank you. I'll pass it to the next person if there is any question.
We have room for one more question.
Okay, maybe I can go to the second question from my side. So you want to use blockchain technology in order to streamline the risk management process, right? At this stage, this blockchain technology that you are using, is it covering all these steps of the risk management process or a specific step? And if the specific step is the answer, which step it is that the technology needs to be implemented?
Oh, that is a great question. And as you see in the title of the presentation, currently it focuses on the assessment portion of risk management, and then also connecting that to the risk analysis. But I think also a great contribution of this system is that all these assessments can be recorded. So I think our next goal is to actually use this to also record any mitigation measures that have been taken and create a platform that they can continuously monitor how the assessments have changed and what mitigation measures have been made in a transparent and traceable way. Thank you.
Thank you very much. Any further questions? Okay, I think there is one question.
This time is only for judges.
Okay.
We will address the audience questions. Yes.
Okay, so I think we are done with the 4-minute time, or is still have time?
No, we don't have still.
Okay, all right, thank you.
All right. Thank you very much. Let's introduce our next participant, Ali Qelmani. His research is on vision-based construction equipment activity recognition. Ali, are you ready?
Yes, I'm ready.
Please start now.
Okay. Hello, everyone. The topic of my research is on developing automated methods for construction activity recognition that has resulted in the publication of 2 journal papers. First, why do we need to develop automated monitoring methods in the first place? Traditionally, site monitoring is performed by superintendents. However, manual monitoring is time-consuming, which has led to the development of many automated monitoring methods. My research is focused on developing vision-based monitoring methods because of advantages like abundance of surveillance cameras on construction sites, which makes collection of vision-based data relatively easy. The other advantage is that by using developments made in the field of computer vision, many high-performing methods have been developed in construction as well. However, there are still some limitations. The first limitation is that, as we can see in the chart on the left, the performance of deep learning methods improves by having more annotated data for training. However, as we can also see in the video on its right, annotating video data is very time-consuming because we must annotate each frame. So the objectives of my work are: one, enhancing vision-based construction equipment activity recognition for productivity monitoring, and two, exploiting unlabeled data by developing a novel self-supervised learning method. However, in this presentation, I will focus only on the second objective. Before explaining my method, I will first explain briefly the main idea behind self-supervised learning. In self-supervised learning, the model usually learns by comparing different parts of data with each other. For example, in the figure of the cat in the methodology section, we can see that the model is needed to solve a puzzle by placing the extracted sections of an image into their original position. So there is no need to provide labels for training. In the method that I developed, I utilized self-supervised learning for videos and for activity recognition. My method is based on contrastive learning that, in essence, trains the model by having it compare different clips that were extracted from an input video and guess correctly which clips are from the same video and which clips are from other videos. To be more specific, as we can see in the middle figure in the methodology section, the clips that are extracted for comparison consider both spatial and temporal aspects of the activities. Moreover, as shown in the simplified spherical figure in the bottom of the methodology section, in contrastive learning, not only we train the model to learn from the similarities between the clips that are extracted from the same video, but also we train the model to learn from the differences with the clips that are extracted from other videos. Finally, after successful self-supervised training, the model learns to distinguish different input activities from each other. However, it still does not know the name of the activities that it has learned. So we need to further train it using only a few labeled videos as shown in the bottom right of the methodology section. Using this method, we obtain close to 82% activity recognition accuracy when only 30% of the data in the dataset was labeled, as is highlighted in the table in the findings section. Also, the figure to its right better demonstrates the advantages of the developed method. In particular, the more unlabeled data we have, the higher would be the benefits of utilizing the developed self-supervised method. Finally, we can see a real-world application of this method in the video in the bottom right. In this video, excavator activities are automatically detected and logged, which can be used for progress monitoring by calculating the excavator work cycle and consequently estimating the volume of displaced soil. Such estimations can play a role in cost estimation of construction projects by enabling project managers to more accurately forecast the necessary resources and time required to complete the project. Thank you.
Thank you, Ali. Now I want to open the session for judges to ask their questions.
Thank you, Ali, for your presentation. Great presentation. I'm Safiatou from Hatch, and I have, let's say, two questions. The first one is, you've been talking about the advantage of implementing the model, but did you evaluate the training process required for the model, and what is the time impact related to that? And my second question is more because I was seeing earthworking equipment. Did you, if I can say, have you experimented the model outside of the earthworking operation, and what was the result on that?
Well, thank you for your questions. To answer your first question, like the training time usually, well, it's not noticeably higher than when you train using supervised and labeled data. However, the main goal of our method is to provide as accurate model as possible during the testing. So even if we need to invest more time during the training, it's not a matter. However, in our case, like usually the training is not like, usually took around like, I don't know, 12 hours to 14 hours to train the model that during the self-supervised stage. And the fine-tuning using labeled data, because it's only a few labeled data, so that usually does not take much time. And relating to your second question for the testing in different environments, well, we have tested in our data, which had around more than 1,000 videos of different construction sites. So we have tried to make our data set as general as possible, to include different weather conditions, site conditions, equipment, and video angles. So we have tried to make our method as general as possible. However, still we would need more data for it to be completely applicable in all scenarios, which is where the advantage of the self-supervised method shows itself. So I don't know if I answered your questions.
Is there any other questions? No? Thank you. Okay, so let's go through our next presenter, Ming Shu Lee, with research on enhanced construction cost estimation of highway projects using emerging machine learning. Are you ready to present? Ming Shu, are you ready? Are you with us?
Oh, yes, yes. Can you
Floor
hear
is
me?
yours, please start.
Hello? Okay.
Please start now.
Yeah. Good day, everyone. I'm excited to share how we can revolutionize construction cost estimation for highway projects. Imagine a world where every highway project is completed online, within budget, and without the headache of financial surprises. Sounds ideal, yes? Yet this vision contrasts completely with today's reality. Traditional methods for construction cost estimation have often fallen short, leading to significant discrepancies between expected and actual costs. These aren't just numbers on the page. They represent delayed commutes, stretched public funds, and projects hanging in the balance. Let's dive into the heart of the problem. State departments of transportation frequently encounter the problem with their estimates misaligned with actual bids. Their cost estimates for highway projects often miss the mark compared to the actual bids submitted by contractors. This discrepancy isn't trivial. It's a multi-million-dollar dilemma leading to cost overruns, project delays, and in some cases, complete cancellations. This challenge underscores the urgent need for enhanced estimation methods to ensure efficient use of public funds and bolster confidence in project planning. Our mission was clear: harness the power of emerging statistical modeling and machine learning techniques to revolutionize how we estimate construction costs. We began with a temporal analysis, employing ARIMA-X models to understand how various market and economic factors impact the deviation between owner's estimate and submitted bids. We then delved into project-level factors through survival analysis, identifying key drivers of inaccuracies and utilize the information to picture the likelihood of inaccurate cost estimates. Finally, at the pay item level, we harnessed machine learning and text mining to retrieve useful information embedded in project development documents and refine early phase cost estimates for critical components like traffic control and grading complete. Our findings are transformative. By predicting the ratio of low bid to owner's estimate more accurately, transportation agencies can track and monitor the market conditions to properly schedule their programs and design appropriate risk mitigation strategies. Survival analysis revealed specific project and market characteristics that significantly impact estimation accuracies. Owner organizations can anticipate cost discrepancies before they escalate. Moreover, our machine learning models for early phase cost estimation provide a precise tool for cost estimators, significantly reducing the margin of error. The web-based application elevated the status of industry practice, helping designers and cost estimators with a flexible and intelligent platform for early cost estimation. In closing, our research marks a significant step forward construction cost estimation. By integrating statistical modeling and machine learning, we offer a multi-level analytical approach that enhances the accuracy and reliability of cost estimations. This not only aids in budget allocation and project planning, but also paves the way for more sustainable and efficient infrastructure development. Thank you.
Thank you. Is there any question for Meng Shung?
Is it on already? Okay. Thank you very much for your presentation. I'm Roxanne Gibralt from Turner & Townsend. I guess my first question is, what is the biggest challenge you're anticipating in implementing this new technique?
First of all, should be the the access to databases. So, for example, the early cost estimation for lump sum pay items. So, since this is the early phase cost estimation, so design details are not available yet. And the lump sum pay items are items where quantities for individual work items are not available. So it adds to the difficulty for accurate cost estimation. Therefore, we need to retrieve the useful information from unstructured text documents. These are project development documents that are available during early phases of projects, such as the concept reports, reconstruction status reports, and field plan reviewing reports. So I think this is one of the biggest challenge for accurate cost estimation, and we leverage the power of text mining and machine learning techniques to solve it.
Thank you.
Thank you.
Thank you.
I only had one question, so do you have any questions?
There's not any other question?
Sorry, it was pretty clear.
Okay, our last but not least presenter is Mizanur Rahman, the research entitled Optimizing Offsite Construction, Integration of Advanced Linear Scheduling Method with Multi-Objective Optimization Model. Are you ready to present?
Yeah, I'm ready.
Please start now.
Okay, thank you. Can you imagine Canada need to build 5.8 million homes by 2030? So is it possible by the traditional construction method currently have? The answer is no. So we need some sophisticated technology to achieve that goal. In this respect, offsite construction can be one of the potential solutions because it can minimize construction time as well as improve productivity. So you may ask, what is offsite construction? Offsite construction is a technique where building component, for example, wall, floor, roof, are fabricated in a factory, transported to the site, and installed on site. So like is like a car manufacturing, but this is for building. So offsite construction actually basically three phases. That means production, logistic, and on-site installation. However, my research is mainly focusing on the offsite production. That means factory environment. So are there any challenges in the factory? Yes, there is some challenges. For example, there is no comprehensive scheduling method to manage the offsite construction currently. And because of this, the manufacturer are facing difficulties to determine the process time for each panel at each orchestration and how many workers they should deploy at each orchestration. And another problem is the production line always is unbalanced. Unbalanced meaning there sometimes the orchestration or workers remain idle, meaning they don't have works to do. And sometimes the panel also waiting for the orchestration. So this is a very challenge to how to balance this production line. Therefore, the objective of my PhD research is to develop an integrated production scheduling method to overcome these challenges. And in this respect, I actually developed a integrated scheduling method that I combine few approaches, for example, Monte Carlo simulation, where we have collected the data from the factory and fit into the triangular distribution and determine the probabilistic process time for each panel at each orchestration. And in order to identify the ideal number of workers, we adopted some technique like space constraint and a lean principle like takt time. And especially for developing a schedule, we developed a advanced linear scheduling method. So now you may ask why we need an advanced linear scheduling method, because there is a linear scheduling method already exists. But for linear scheduling method is perfect for the traditional repetitive construction method, but for offsite construction, it cannot ensure the logical sequences that occurred in the factory.
1 minute left.
So to solve this problem, but the LSM cannot generate an optimum production schedule. To solve this, I actually developed a multi-objective optimization algorithm, and this method is implemented in a real-life wood-based panelized construction in Canada, and the result revealed that the method effectively can develop an optimized production schedule where they can identify the ideal number of workers and sequence of production, and it can reduce the project completion time, orchestration idle time, and work in progress time effectively. Last but not least, this method it solves so many problems that facing the industry people, especially in the offsite construction. Thank you very much.
Thank you. Judges, questions?
Hello, thank you for your presentation. I'm Christophe Guidon from Rivet. I have some questions for you. First one is, how do you capture the excessive work in progress or the extreme workstation idle time? Do you think is it automated?
In my schedule that I develop from the time, that means for a particular orchestration, how long waiting for a panel. So that is orchestration idle time. So it's from the scheduling method I developed. From quantitatively, I estimate how much. And work in progress time, the panel actually how much, that means the bottleneck. I can say the work in progress is like a bottleneck. So how much time the panel waiting before go to the next orchestration. So it's actually quantitatively my scheduling method is can estimate.
Okay.
It's not simulation. It's not simulation.
Okay.
Yeah.
Second question I have is, when you hear about Monte Carlo simulation, usually it's very complex for risk management. So did you manage to make that easy for a factory company, like a small size company, to use it by themselves? Or do you need a PhD student to be there with them?
Okay, well, that's a very good question. But this Monte Carlo simulation, I actually developed my own algorithm. Like so, just the factory people need to input how much from the historical data. They need to give only the productivity. For example, minimum, maximum, and average productivity, and it automatically gives the result. The probabilistic process time for each panel at each orchestration. For example, if the panel is small, processing time is lower. Panel is big, is the processing time is big. So it's depending on the panel size, right? And the factory productivity data, it automatically calculates the process time. And this probabilistic time is coming from the Monte Carlo simulation.
Okay. One more. Last question. So you say it was applied to wood panel production. Do you think it's easily scalable to a like full size house when you add more trades like electricians, plumbing, etc.? Like more complex production sites?
Well, actually, this my research is mainly focused on the production line. For example, is considering the orchestration. That means the workers, not others. The workers or crew or machine that need to produce the the orchestration. Not other thing is included. For example, as you say, is electrician, all this. No, currently this model is not included. That
maybe in the future.
Yeah, maybe. Yeah, I can consider it. Thank you.
Thank you.
Thank you, judges. Any other question? No? All right. So thank you, everybody. This is the end of the first stream. Now I would like to pass the floor to my colleague Am to moderate the next part. Thank you. Over to you, Am.
Thank you, Dilaram. This is Amr Alam. But just before I start, I just want to give some time to Muaz and Kimia to collect the questions from the audience. All good? Hello, everybody. I'm thrilled to be here for the second year to moderate the AACE 3+1 construction elevator pitch competition. I think we need to consider shortening this, the title of the competition. So anyway, but I see a different crowd this year. I think we have learned our lesson from last year, and we didn't schedule the competition on Valentine's Day. So I can see happy couples and singles. So good job, guys. I apologize to the singles that may be alone this Valentine. So anyways, let's continue our competition. Ladies and gentlemen, and carry on with this marathon of best pitches. Our second stream today is about automation, digitalization, robotics, and construction. So many buzzwords. So I'm confident enough that some or not all of the contestants of today will change or will shape the construction industry. So please, judges, we don't want the innovators of today, when they become billionaires in a couple of years, they end up saying that we were competing here and we didn't win. So without any further notice, let's kick off our first finalist of this stream. So please welcome Surush Abasapur.
Thank you very much.
Surush, are you with us? Are you ready?
Yes.
Okay,
Yes.
Surush, you have got 4 minutes. Your time starts now.
Thank you very much. Good afternoon, everyone. It is my pleasure to present my work today to you. So do you know that over 50% of facility management activities in the North America were outsourced to contractors by 2019 while keeping a consistent growth? This is happening where the facility management activities have seen a rising trend over the past decade. The expenses reaching
Surush, sorry to interrupt you.
Yeah.
So can you please start over? We are sorry for this inconvenience. So your time starts now.
Okay. So do you know that over 50% of facility management activities in the North America were outsourced to contractors by 2019 while keeping a consistent growth? This is happening where the facility management activities have seen a rising trend over the past decade, with expenses reaching to $387 billion US dollars in 2023. And it is also anticipated to have an increase by 21% by 2029. Also, depending on the service life of various types of buildings, the operation and maintenance expenses can account for 60% of total life cycle costs. This market situation provides a huge opportunity for contractors who are aiming to secure more profit by leveraging the facility management services. However, contractors usually face several error-prone manual challenges in the process of prioritizing the maintenance orders. The maintenance orders are actually the takes-based facility management requests that come from end users. So the challenges for contractors are the categorization, evaluation, scheduling, and financial monitoring of maintenance orders, and also the resource allocation. To address these challenges, a prioritization system has been presented to support contractor tactical financial management actions. Firstly, the natural language processing and data mining techniques have been applied to prepare the free textual maintenance orders data and recognize and categorize them. Then, by integration of financial data and creating portfolio cash flow, the significant contributors of maintenance orders in terms of frequency, I mean the most demanded ones, and financial aspects, cost, profit, and net cash flow were analyzed. This step encompasses both preventive and corrective maintenance orders, providing insights from patterns among historical data. After that, The portfolio cash flow is optimized through a multi-objective scheduling optimization considering constraints. The goal is to maximize profit, stabilize the cash flow, and reducing the overdraft magnitude. This process is dynamic, allowing for continuous improvement as new maintenance orders are added to the portfolio. Optimization focuses on only scheduling preventive maintenance orders, which constitute the majority of facility management requests and have more flexibility in scheduling. This process is also capable of leveraging the ongoing data. The data-driven decision-making tool offers various
1 minute left.
In an automated manner by recognizing the main maintenance orders contributors, maximizing the profit, improving liquidity, and reducing the financing needs, and also improving the budgeting and labor allocation efficiency. The system has shown promising initial results in MEP, mechanical, electrical, and plumbing maintenance orders, demonstrating its potential for customizing and broader application, including construction phase services. Thank you very much for your attention.
Thank you, Surush. Well done. This was 24 seconds under the wire. Well done. So now we are going to open the floor to judges. Judges, I've got 3 minutes for questions. Yes, sir.
Thank you for your presentation. Christophe Guidon from Rivet speaking. It looks like a very interesting tool for contractors. However, if I were a client and an owner of a building, I'm not sure it would please me to know that your goal is to maximize profit. So I'm wondering if you took into factor client satisfaction, for example, considering like how you can assess decisions that would improve maybe life expectancy of the building or other objectives rather than only profit optimization on the contractor side.
Yes, good question. The first thing is it actually helps to assign the labors of the contractors to doing the preventive and corrective maintenance in a timely manner. So it, on one side, helps owners to do the orders in a timely manner. Another side, for, as you mentioned, for profitability of the clients. Actually, I didn't see in this viewpoint, because usually the economic viewpoint is related to contractors, but owners can benefit from this system in two things. First is the kind of agreement, legislation to doing the timely manner of the things smoothly. And also another thing is the categorization of maintenance orders.
Okay. Maybe another question. I'm not sure I understood. How do you feedback into the loop sorry, how do you input back into the loop the feedbacks from the actual labor? Because if you only take decision from, I think it was in your flow chart, the financial data, how do you make sure that there is another way to input actual people actions in it?
You mean the labors of contractors?
Yeah. So, for example, if he follows a change order and he goes to some stuff, and then does he have a way to input back into the system? Well, this seemed to be very profitable. However, working outside during the winter at a high floor was not that good idea, or?
Yes, you know, the benefit of this system, it can be customized to several things, aspect that contractors, if needed, to apply. One of them is labors, that they, if can see some constraints, and I see the labor constraint in my optimization model, because we have three type of labors: foreman, journeyman, and the labor. So now we incorporated these types of labors in our system, but the problem is, as you mentioned, for during winter. So yes, it can be customized based on the client needs and situation that contractors are working on.
Thank you.
Thank you. Thank you, Sarush. Now let's move from the financial management part to the human-robot collaboration. Please welcome Shayan Shayeteh. Shayan, are you ready? Shayan. We can't hear you, Shayan. Wait a bit. I think maybe you're mute. Shayan, can you hear me? Please raise your hand if you can hear me. Okay. Shayan. Move on. Okay, for some technical issues, we are going to move on and begin with the. Yeah, we are going to introduce our third presenter today, Rafaela Orenga Panizza. Rafaela, are you ready?
Yes, I'm ready.
Okay.
Can you all hear me?
Yeah, we can.
Okay.
So, Rafaela, your time starts now.
All right. Thank you, Amr. I would like to start this presentation by asking a very important engineering question. Did you ever purchase second-hand clothes from a thrift shop? Very engineering question, but let's go on. If not, maybe you have donated some of your old clothes to a Salvation Army, or even sold some of your nicer ones to a vintage shop. Regardless of where you fit into this scenario, I'm sure you're familiar with this common circular economy practice of buying and selling used apparel. In fact, this resale market has been growing exponentially in the past few years and is said to be worth $350 billion by 2027 globally. But the question now is, how does that relate to construction? Well, like the construction industry, the apparel industry also follows a linear economy model. And this large-scale adoption of a resale market is a key practice for both to shift towards a circular economy. Now, you're probably thinking, and you're right, things are a bit more challenging in the construction industry, because while the process of taking old clothes out of your closets is extremely simple, the same cannot be said about extracting building parts from the buildings, obviously. And to do so, deconstruction is key to salvaging building parts. But the thing is, it is also more labor, time, and cost intensive than the common practice we're all used to, demolition. So this is where my research comes in. With the help of computer vision, I'm leveraging widely available images from low-rise residential buildings across the city of Montreal to extract their composition. This will then allow us to decide which components and materials can be recovered. This collected information can then be used to help the implementation of circular economy practices by accelerating the deconstruction planning process from a variety of angles. From the owner's perspective, for instance, this will allow them to more quickly identify the potential profits that can come from recovering their building parts, thus helping them decide if deconstruction is worth it for them or maybe not. From the city's perspective, this information can facilitate the permit issuing process by potentially eliminating the need for inspection, therefore also speeding up the overall process.
1 minute left.
Thank you. And lastly, from the deconstruction contractor perspective, this information allows for a more efficient deconstruction planning phase, where focus can be given to the components of interest and therefore accelerating the deconstruction process itself. So to wrap this up, my research aims to use the help of computer vision algorithms to facilitate the deconstruction planning phase, therefore playing an essential role in advancing circular economy practices within the construction industry moving forward. Thank you very much.
Thank you, Rafaela. Well done. So we are opening the floor for judges to ask.
Thank you very much, Rafaela. I'm a big fan of secondhand clothes, so thank you. My first question would be around, so you mentioned that this would be for a low-rise building, right, around Montreal. So if this is a big success, how would you integrate this for higher buildings?
Well, firstly, my focus is now on low-rise buildings, mostly because those are the ones that end up getting demolished more often, and also the ones that we have a bigger pool of them. So I'm focusing on them because I'm using some assembly types information for us to move towards a higher rise buildings. Then we would have to do this study and look into archetyping them as well as collecting image data that will cover the entire building.
Okay, thank you. My second question is, did you think about, because recently we've heard about like prefabrication. Did you think about that aspect in your system, or did you how would you integrate prefabrication into that methodology of yours, like in the future? Of demolition, like what kind of difference would it make? And like have you thought about it? Like my question is just
Yes, well, definitely the focus now is for the existing buildings, for the specific reason that they were not built to be disassembled or deconstructed. So that's one of the main reasons why the process is much longer for them. Things will definitely get much simpler when the buildings are actually designed for that. The processing time wouldn't be as long. Yeah, so maybe we would have this data a little bit more integrated from the newer buildings compared to the older ones, but that could definitely be something to be considered.
And I guess the third one would be, what are you anticipating as the biggest risk for building owners?
Well, I believe,
or maybe there's no risk. I mean,
the risk would be to pay more money. I believe the risk would be to end up spending more money than you are anticipating. That is definitely a risk that will come in future works, to then be able to look instead of just the components, like their condition assessment, to see if this component will actually be able to be resold, for example. I would say this is the biggest risk.
Thank you very much.
Thank you.
Any question?
Any more question? So we are wrapping this question round. So let's please welcome the fourth presenter of this stream. And he's not a normal presenter of today. He's the winner of this competition in 2022. Please welcome Amit Oja. Amit, are you ready?
Yeah, I'm ready. Can you hear
Are
me?
you ready to win this competition too?
Hopefully.
Okay, Amit, you have 4 minutes. Your time starts now.
There are some animations, so could you do that? Yeah. So, hello everyone. Good afternoon, everyone. Today, I'm excited to discuss the emerging role of powered back support exoskeletons in the construction industry and the underlying risk and socio-technical challenges associated with their implementation. This research funded by NSF aims to shed light on these critical aspects. So, as you all know, construction industry is a labor-intensive industry where the construction workers have to do a lot of physically intensive tasks in awkward postures for a prolonged period of time. So this puts a biomechanical strain on their musculoskeletal system, causing work-related musculoskeletal disorders. So among the work-related musculoskeletal disorders, back-related WMSDs are the most prevalent form of musculoskeletal disorders, where the incidence of back-related musculoskeletal disorders is twice that all of the industries combined. So for this reason, powered back support exoskeletons are emerging as an ergonomic solution. So there are two types of exoskeletons. One is powered, one is unpowered. So here we are talking about powered because they actively augment the human body for relief support, for weight dispersion, for posture correction. So they have potential to be implemented to reduce that risk of WMSDs. But they haven't been widely implemented. So the reason of the lack of implementation, widespread implementation of exoskeletons are mainly three. So first, there is lack of understanding of the socio-technical challenges, the perceived usefulness, ease of use, risk perception of using exoskeletons. Second, there is lack of understanding of the physiological challenges, potential changes in the posture or movement control mechanism with the use of exoskeletons. There is not a in-depth understanding of that. And third, there is a lack of understanding of impact of exoskeletons on worker physiology, on worker psychology. Sorry. So if it affects the workers' attention level, or if the workers have trust issues with the technology, so we don't know that. So in this regard, the goal of my research is to understand the underlying physical and psychological risks and socio-technical challenges of powered wearable exoskeleton to construction workers. So for that purpose, to achieve this goal, there are three objectives. First objective is to understand the socio-technical challenges of back support exoskeletons in construction. Second was to develop a novel virtual reality platform for high fidelity simulation of construction tasks to be executed with those back support exoskeletons in a safe manner so that we can properly assess the physical and psychological risks in safe. And third objective was for worker-centered physical and psychological risk assessment. So talking about the results for my first objective, so from using socio-technical system theory, we developed some questionnaires, and the questionnaire was sent to construction professionals nationwide in US. 200 experts were contacted and 105 responses were received. And upon analyzing the responses, the most significant barrier were the concern about the usability, the willingness of use, that was another significant barrier. And third most significant barrier was concerns with the productivity. Similarly, the least significant barrier were the hygiene issues, the false sense of safety, and the peer acceptance. So this is my results for the first objective. Now the results for the second objective of developing a novel virtual reality platform. So
1 minute left.
we create a realistic scenario of a construction site and integrated that with a tangible interface so that we could provide a high fidelity simulation of construction sites, and we could properly assess the physical and psychological risks. It was like a test bed, so to assess the risks in a safe manner. And third, about the worker central physical and psychological risk assessment. So we are focused on about the physiological risks. So we checked if there is any change in the if there is any ergonomic risks with the use of exoskeletons. We compare the subjects working with exoskeleton and without exoskeleton using REBA method, and the method suggested that the subject with back support exoskeleton, their ergonomic risks was lower. Similarly, we also check if there is any change in the energy expenditure or metabolic risks with using exoskeleton and without using exoskeleton. So we found out that there was significant reduction in energy expenditure by 17% when performing tasks using exoskeleton. So this is my physiological risk assessment. My future step is the psychological risk assessment. So thank you everyone. If you have any questions, then.
Thank you, Amit. Judges, 3 minutes to grill.
Sure. Thank you, Amit, for the presentation. I am Shayan Shayeteh from Concordia University. My first question is related to the use of exoskeleton with regards to the construction tasks. I believe that the construction workers use this facility when it comes to doing manual task, variety of manual task and construction processes. What type of construction task you had under your research when you were basically analyzing the data? And if there is more than one task, how did you categorize these tasks based on the most challenging and the least ones?
Thank you for your question. So yeah, there are different tasks, and we mainly focus on the material handling tasks. And also, we focuses on the rebar tying tasks. So we categorize the tasks based on the ergonomic pressure that the workers might face. Because for the bricklaying tasks, the back is at more, the back support exoskeletons, the back muscle is at more risk when doing the material handling tasks. Similarly, for the rebar tying tasks, if you are awkward posture, back is affected, but the knee is also affected. So we divide them into the body parts also. So we are analyzing that part, but right now we focus on the ergonomic risk and the metabolic expenditure. But we have 2-3 tasks, mainly the material handling tasks, rebar tying tasks. We also have the bricklaying tasks, and we are doing the research like that.
See, any questions from the other panelists? Okay, maybe I can go for the second question. You mentioned that exoskeleton they're found to decrease local muscular fatigue and improve the ergonomic posture, right?
Yeah.
What percent of decrease or improvement are we talking about now?
For which part? Sorry, for the muscular fatigue or for the?
So for the decrease in local muscular fatigue. So quantification wise, what percentage are we talking about?
So it depends upon the muscle. So from our research, we found out that the lumbar erector and spine, the back muscles, the fatigue was decreased by 15%. So it depends upon the muscle. So here we found out that the lumbar erector spine, the back muscle, it had significant decrease in the muscle fatigue.
Okay, thank you. No question.
No more questions. Thank you, Professor Shaheen. So we are going to go back one more time to Shayan. Shayan, can you hear me?
Yes, can you hear me?
Yes. So can you share?
Okay.
Very good. Okay, Shayan, you have got 4 minutes. Your time starts now.
Hello, everyone. Sorry for the technical issue. So I'm presenting my research titled Enhancing Human-Robot Collaboration in Construction, an Adaptive Human-Machine Interface Approach. As you probably know, construction robots are starting to emerge in construction sites to actually support human workers during physically demanding tasks. There are several examples of these robots, like bricklaying robots or material handling robots. In most of these cases, human robots need to collaborate with each other, meaning that they need to physically interact with each other. The complexity that is often found in many construction operations requires the safe and efficient integration of workers with these new advanced technologies. But the problem here is that the current human-machine interfaces are not quite suitable to meet the diverse needs of individual workers in construction sites when it comes to the collaboration with robots. So to address this issue, my research aims to develop an adaptive human-machine interface to enhance the human-robot collaboration in construction using the power of immersive technologies, physiological sensing, and artificial intelligence. So the overall framework of my research can be divided into 3 main objectives. The first one is to develop a multimodal sensory information mechanism that helps the worker understand the status of the machine in near real time. I use multiple modes of communication, including visual cues, auditory cues, and kinesthetic cues to facilitate the interaction between the user and the machine. And now that we communicated the status of the machine to the user, the second objective is to establish a human state informed mechanism to identify the user response and communicate it to the machine, so the machine also understands the user. For this, we needed an objective and reliable method to assess the user response and transfer it to the machine. For this purpose, I used uninterrupted measurements of physiological responses of the workers using wearable biosensors and measured 3 metrics, including cognitive load, trust, and selective attention. Finally, the third objective is to develop a co-adaptation mechanism to be able to adjust the performance of the machine based on the user response that we captured in the previous step. For this, I developed a control mechanism that could adjust the system by providing some cognitive aids and private feedback to the user, also changing different elements of the system to kind of deliver a personalized experience for the user. To evaluate the performance of the developed framework, we conducted several case studies. The first one was to evaluate the performance of the multimodal sensor information system. We evaluated the impact of the developed visual cues and also the haptic cues on the workers. We evaluated their situational awareness and also their engagement during different human-robot collaboration tests. In both cases, the selected metrics improved when using our proposed system compared to the traditional simulation. In addition, we also evaluated the performance of the physiological signals, including the EEG, EDA, and PPG in measuring cognitive load of the workers. I've used a deep neural network architecture and interpreted the captured signals and were able to achieve a high accuracy level. And we also evaluated the performance of the adaptive system and developed the decision model, which was resulted in high accuracy as well. To summarize, this research proposed a novel human-machine interface for enhanced interaction with construction robots, which can contribute to increased safety and productivity in the construction sector. Thank you.
Thank you, Shayan. Now let the judges judge.
Thank you, Shahan. I'm Safiatou Maiga from Hatch. Thank you for your presentation. My first question, you've been talking about the fact that the experimental results show that the system significantly improved the user experience. Can you quantify that in percentage?
So we tried to measure different metrics, like, as I mentioned, the situational awareness and user engagement in this case that I presented. So I cannot exactly remember the percentage, but the results were significant, statistically significant, with the 0.05 significant level. In terms of exact percentage, I cannot exactly remember.
That's okay. Someone else have a question?
Any more questions?
I have one. I was also wondering if you see any challenges in implementing the human machine interface, the model right now that you have.
Yeah, that's a good question. So for the challenges, we use like wearable biosensors. So one challenge is the use of these sensors in the field. So capturing reliable and high quality signals can be a challenge. So we're working on different, signal processing methods and optimization methods to be able to capture high quality signals in the field. So this is one challenge. The other challenge can be maybe acceptance of these new technologies by the workers. And that's why we use like the trust as a method to kind of measure this user response during this working with robots. So these are what I can think of.
Thank you, Shayan. This was the last presentation of the stream. Now we are going to open the floor for the audience award. All the audience can scan the QR code and vote for the best presenter from your point of view. So please take a moment and vote for your best contestant. So are you facing any difficulties to scan the code or all good for the audience? All good? So thank you for being here. That's it for the second stream of this day. That's it for me. Over to you, Arham.
Thank you very much, Ham. I'm sure that today is not easy to be in the judge's position because all presenters in the first part have done great job. Many congrats for that. Now, everyone, guess what? The excitement doesn't end there. The second part of the competition is just about to start. So please make sure to adjust your seatbelts and enjoy the next part. My name is Aram Martinez. I'm a PhD student in building engineering. I'm planning director and operations director in AACEI Student Committee Montreal section. I have the great pleasure to be the moderator of this section, but just before starting, I would like to remind everyone that at the end of this section, we will have the opportunity to vote for your favorite contestant. We will show the QR codes. And I also would like to remind you that we are collecting questions, so please write down your questions. Now, would you believe me if I tell you that our next contestants were challenged to pitch their research in less than 1 minute? Yes, you heard it right. Not 4 minutes, 1 minute. What a challenge, isn't it? Now, I would like. Would you believe if I tell you also that they accept this challenge? So they are going to showcase and present the research under this time constraint. This not only requires creativity and ingenuity, and the ability to communicate and deliver the valuable research to the audience under this time constraint. We are about to witnessing the presentations under the theme number 3 on sustainability and infrastructure, aiming at tackling challenges such as meeting the current growing population housing demands, looking at more efficient construction methods, ensuring high quality infrastructure, and reducing environmental impact while meeting retrofitting needs. I can't wait to see their presentations. Please show us what the contestants present.
Hello. Hello, everyone. My research topic is identifying gaps in the building rating system for zero carbon goals. This research aims to explore the gaps in the current rating system in New Zealand to achieve zero carbon goals in 2050. In this study, I hope to explore the professionals' viewpoint on the current rating system in New Zealand, technology accessibility, and sustainable materials related to these systems. In addition, the driving force and the barriers for adopting the New Zealand green building practices. At the end, find out the optimized directions for New Zealand system rating tools. Thank you.
Hi everyone, my thesis titled Innovative Construction in Canada's Extreme Environments, Combining Computation Design, Digital Fabrication and Modern Chamber Technique. I started by categorizing extreme environments and analyzing 6 projects across different climate zones, including any cross-industry construction. The heart of my research delves into Nunavut's housing crisis, highlighting the importance of creating sustainable, affordable homes. My methodology combines tools like Grasshopper, Amoeba, and Karamba 3D to design a house that can be built with 3D printed materials and prefabricated cross-laminated chamber CLG. This approach aims to cut transportation cost and construction time, making it a viable solution for Nunavut's communities by using local resources for 3D printing. This project is a step towards solving the house crisis in extreme environments, making homes more accessible and paving the way for sustainable construction future.
Prefabricated construction represents a significant advancement in the realm of the construction, elevating disassembly practices to a more prominent position. However, a crucial challenge is the underdeveloped market demand. To reuse the disassembled components and bring them back to the circular construction framework, we are working on optimizing a reverse supply chain with a focus on the locations, operations, and types of hubs. The developed model will minimize the cost and environmental impact related to the establishment of new hubs and transportation and operation in hubs and factories. This model is based on the condition of disassembled steel and concrete components using BIM data and on-site and off-site quality inspections. The optimization model is realized using a genetic algorithm and data from GIS. This model targets 5 main nodes: disassembled site, hubs and warehouses, factories, recycle centers, and new building sites. The proposed method is expected to result in cost-effective and environmentally sustainable circular construction.
One of the main iconic bridges in the Twin Cities has collapsed.
The entire bridge is in the water. 35W bridge is in the water.
While bridge failures are not common, the result is catastrophic. Many bridges in North America are more than 50 years old, and the current method to monitor them is inspection, which has a long time span and cannot detect structural integrity and behavior. The solution lies in a live model, the digital twin. It acts as a virtual representation that updates in real time through sensor data, offering feedback and prediction. As seen here in our collaboration with Time6, we found that available methods like finite element and machine learning fall short for digital twins due to issues like data integration and reliance on data quantity and quality. This is where physics-informed machine learning comes into play, integrating physics and data. Seeing the early stage of my work, modeling an RC beam using physics-informed neural network, I can say this method is allowing us to create a digital twin that evolves alongside the structure in real time to be preventive of sudden failures.
Thank you very much. Now it is time for our last, but not definitely the least, theme of this year's competition, Robotics and AI. Our last 4 presenters will enlighten us by showing to us the latest technological advancements, some of the latest technological advancements to streamline construction processes, ensure worker safety, and train workers on the field using VR. Please let that video run.
In the United States, over 80% of homes feature shingle roofs, of which around 70% are made of asphalt shingles. Roofs plays a vital role in the energy efficiency system of buildings, and damages such as curling, missing can lead to increased energy waste. Present challenges in human roofing and inspection encompass fatal safety issues, labor shortage, and inaccuracies. Existing studies, including drone inspection, are facing challenges like poor image resolution from distance and instability, environmental obstructions like shadows and debris, and short battery life. We introduce an innovative system that merges advanced robotic perception algorithms with an intelligent slope-adaptive robot platform. The system's robotic perception part leverages state-of-the-art computer vision models and algorithms for testing on the robot platform. And the robot platform is designed under the principle of slope-adaptive, affordable, user-friendly, easy to build, and extension compatible for future functions such as installation.
Hello everyone, my research focuses on attic insulation, which is important for indoor energy efficiency with a large potential market. However, this operation comes with intensive labor and severe safety risks. Despite the rapid development of construction robots, we still lack an integrated robotic system to automate this work. Specifically, we need an agile platform, a robotic perception, and a control system in complex static spaces. Our solution bridges this gap with an innovative robotic platform. The first part features a compact drone equipped with a finger gripper, providing agile control. Secondly, the perception model combines advanced vision model with LiDAR scanning mapping, achieving 90% intersection over union for segmentation in low light conditions. Finally, we design a SLAM-based navigation system to enable the drone adaptively avoid obstacles, achieving over 95% success rate to reach target.
Hi everyone. The construction industry now for a very long time has been adversely affected by health and safety related issues, and wearable physiological sensing technology offers the potential for developing real-time worker-centered health monitoring system. My research is focused on developing a holistic health monitoring framework and comprises of three major components. The first component is an integrated biosensor design, and for now, we are developing flexible sensors for acquiring physiological signals. The second component is developing AI-based health monitoring models, and we have developed a multimodal physical fatigue estimation model based on signals like PPZ and ECG. The third component is developing an effective representation and feedback system for construction workers and managers, and for now we have developed a large language model-based feedback systems for construction workers. The project intends to increase the overall health and well-being of construction workers working in construction sites. Thank you.
The construction industry is facing significant challenges, including skilled labor shortage, low productivity, and safety concerns. Robotics are frequently presented as the alternative to assist workers and alleviate these problems. However, this leads to the new challenges in worker-robot collaboration training. This dissertation introduces a novel VR training system funded by a National Science Foundation grant. The system marks by focusing on a worker-centric approach. First, it features real-time body synchronization within a simulated construction environment, and the workers' learning performance improved by 46%. Moreover, the adaptive training model utilizes both objective and psychological feedback to adjust the training content dynamically, and it boosted workers' performance by 70%. Finally, the comprehensive human-robot collaboration training platforms are built. The results highlight VR's ability to improve worker skills, in providing a foundation for future VR training studies.
Thank you. What a great job for the 1 minute format presentations. Please join me on an applause. Congratulations, champs. Now, dear audience and respected judges, it is time to vote for your favorite contestant. Under this second section of the competition, the QR code is now shown and the link to vote for online audience is also shared. Please do so. You have a couple of minutes. You can. One more minute, please. and you will have another chance at the end. Well, thank you for your votes. I pass it to you, AACEI. Thank you, everyone.
Thank you, everyone, for the wonderful presentation we have just witnessed together. Each of them truly was a showcase of creativity and hard work. Now, I'd like to invite our judges for any final thoughts, comments, or feedback you might have.
No. Yeah. Okay. No, I want to thank all the participants for their hard work and the quality of their presentation. I think we're all very impressed by what they showed us today.
He said it also.
Thank you very much. We have collected some questions from audience and industry professionals during the presentation. We will go only through 4 of them because of the tight schedule. And we'll start with Amit. Amit, are you here with us?
Yeah, I'm here.
I have a question here. How did you consider the physical loads in the virtual reality environment?
So in virtual reality environment, we had a tangible interface, but the load were real. So to make it a realistic simulation, so if you can see there is some tracker in the load in the side of tangible objective. So the simulation was in the virtual environment, but the load was real in the realistic environment. So it was like that.
And how did you manage the subjectivity of data you collected from experts?
Subjectivity of data collected from the experts.
Mm-hmm.
So because the data was collected from different, not only from workers, from construction professionals, and in different geographical regions of the country, from different structures of the workers from the different structure of the company. So I think that manages the subjectivity of our data. Because we are not generalized focused on one group of workers or something. We're focusing on managers, safety managers, construction professionals, construction managers, workers, the different levels of the workers from the company. So I think that we are separation. Yeah.
Thank you. The next question is for Shayan. Shayan, can you hear me?
Yes.
How did you consider the human-robot interaction in terms of socio-technical aspects? How workers feel comfortable to work with or beside the robots? To work with or beside the robots?
Yeah, thank you for the question. So that is one concern. So regarding the experiments, so we had like a explanation before the start of any experiments, and we explained the experiment and the scenario and the human-robot collaboration for the subjects. In real world, so this is something that needs to be worked on to how to prepare the workforce for the efficient human-robot collaboration. So the scope of my work, I think that can be like a future step.
Okay, thank you. The next question is for Imbai.
Sure, I'm here.
Is there any step that you consider for selection of systematic risk or a specific risk? How did you consider there are systematic or a specific risk?
I see. That's an interesting question. Um, I believe if it's a very specific risk, all these participants, they can have different perspectives on it, such as the probability of occurrence and its impact on the project cost. So it's really important to have everyone who have different perspectives on this risk. The owner would have some experience based on past projects. The contractor would also have a different interpretation on this matter. And we could also have engineers on board as well. So instead of having them all sit in the same room and argue over these specific risks, these can be entered into the system, and based on a list of criteria, their opinions can be weighted to make a joint assessment that is aggregated in the system that will reflect all perspectives and help them make a joint decision on how much contingency they would like to assign on that specific risk.
Okay.
Thank you.
Thank you. With the conclusion of the Q&A session, we officially close the presentation part of our today's event. On behalf of AACEI Montreal Section Student Committee, I extend our thanks to our judges for undertaking this crucial role. And I want to kindly ask you to take your needed time and make your decision about our final winner. Thank you. Also, in addition to our esteemed judges, we have the opportunity to choose an audience from our audience favorite presentation. You will find the two QR codes, one for 4 minutes presentation and the other one for 1 minute recording. And for those joining us virtually, you can find the links on the chat box of the Zoom. Just take your time and scan the QR code or click on the link and vote for your favorite presentation. Meanwhile, the judges make up their minds. We will take a short break and make sure all of you gonna vote. And you can also watch the AC video that we have prepared, and just feel free to enjoy the food and beverages provided for you during the time. Thank you.
I have the things that everybody is waiting for, but I want to tease you a little bit. Talking about the 70 plus years of history of Concordia. No, I'm joking, I'm not.
Well, I joined AACEI in 1982. I was the junior estimator. And they said, Les, you got to join ACE. I said, ACE, what has this got to do with tennis? Tennis ACE, or what is it? No idea. In those days, it was called the American Association of Cost Engineers, which they changed later to the Association for the Advancement of Cost Engineering. Cost and schedule never gets old. It never gets old. Estimating, budgeting, forecasting, doesn't matter what you do. It never gets old. Earned value, contingency management, risk analysis. So AACEI has a lot to offer, and I would encourage you, if you're a student, it's great, or even not a student, but if you're a student, it's a very reasonable price, and you get access to so much information. The library is 6,500 technical articles on every subject in the area. You have access to 100 recommended practices, how to write a basis of estimate, how to write a basis of schedule, all of these things.
Bonjour tout le monde. Hello everyone. My name is Haji Ramani. I'm the current president of AACEI Montreal, Association for Advancement of Cost Engineering. It's an organization, an international organization who takes after professionals who are involved in project management, in project controls, different aspects of it. What we do in AACEI is to provide resources like recommended practices, certificates, courses, books, which really help grow the professionals and this industry itself in terms of practicing the best practices which are out there. In AACEI Montreal, we have a couple of events per year. We invite people to give talks around different topics of interest to the network. One of these events is the 3 minutes speech, which is expanding every year, and it's really a chance for the students to bring up with their ideas, to come up with their ideas, to present their topics, their theses, their projects, to the professional network for us to watch these ideas and to collaborate perhaps in future. If your idea is really good and well received and you're able to present it well, you may be able to walk away with one of the prizes. It doesn't matter really what you're involved in. At the end of the day, this is a great win-win for yourselves and for the AACEI and the crowd of project management controls in Montreal.
Hi, my name is Les McMullen. I'm Global Director of Project Controls at Hatch and member of the Montreal Section Board of Directors. At Hatch, our vision states that we are passionately committed to the pursuit of a better world through positive change. As such, we're very pleased to be a sponsor once again for the upcoming 3-minute thesis competition. This is truly an amazing event that will involve students, graduates, and undergraduates from universities across Canada. For the students, this is a marvelous opportunity to showcase their work and their talents in front of industry owners, consultants, and contractors. On my very first job many years ago, my colleagues advised me to join AACEI. They said it would be good for me. Looking back in my career, I can tell you that becoming a member was one of the best decisions I ever made, that allowed me to work on many interesting projects around the world with many wonderful people. As members, students have access to a great body of knowledge, a vast library, certifications, and the opportunity to associate with people from all over the industry, and it opens many doors. Simply put, AACEI is the benchmark for people in our business. It unlocks the value to skills and knowledge and unlimited career opportunities.
Thank you for inviting me for this important event. I would like to welcome you all participants for the 3 minutes competition from across Canada. I would like to take this opportunity to thank the organizers, the Student Committee of AACEI International, housed here in Concordia, and the Montreal section of AACEI International. The event itself will be held here in the 4th space of Concordia University, and I would like to take also this opportunity to thank the staff at 4th space for allowing us and helping us to use this important facility for this event. All of you participants, I invite you to make good use of that event, learn from one another, showcase your own work, interact with your colleagues and expand your network. And I wish you all good luck and good experience in this particular event. The event will be hosted online for all participants. However, judges will appear in person in the 4th space, along with a number of sitting observants or audiences that are interested in this event from industry and academia as well. But also, before I let you go, I would like to acknowledge and thank former grad students who have established that link with AACEI in the past. Some of them went to take leadership positions in industry, and others are at the rank of full professors at universities in Canada and in the US. So thank them, particularly Samir Al-Omari. I remember Samir. He was behind that effort. So thank you very much, Samir, where you are. Again, for all participants, I wish you having a great time in this event. Learn from one another, showcase your own work, and expand your network.
One. Please find your seat again so we can continue with our parts.
We are going to do that. Thank you very much for that.
Welcome back, everyone. I hope you all enjoyed the break. Please find your seat again so we can continue with our final part of today's event. I want to make sure that every one of you has voted. If not, please vote now because our voting system will be closed in just 1 minute. Thank you. Now it's my pleasure to pass the floor to my colleague Abdelhadi Omar. Continue with the final part of the competition. Thank you.
Hello, everyone. We are back. Before announcing the winners, I'd like to invite Mr. Hajir Imrani, the president of AACE Montreal section, to share a few words with us.
Thank you very much. Hello, everyone. Bonjour tout le monde. I was late and apparently I lost a lot. Apparently you guys have had a fantastic competition so far. So congratulations to the organizers. Apparently this has been the best so far. Every year we say that, and I'm really, really proud of you guys for having organized this continuously with a great improve, do, act, improved, and do again. So you guys are the best that can really be happening. So kudos to you for doing that. Really great job. We at AACE Montreal support you guys and support this event now for about 5 years. Some of you know that across AACE International, AACE is a large organization, an organization that is dedicated to project management in the construction sector and in other sectors, but really mostly in the construction sector. It has a lot of recommended practices, a lot of expertise in terms of how do we build, what are the best practices there. And it's a large organization with over 100 countries, in which people are active. And this event is one of those top events, which actually is the best across the entire AACE. Many people are interested to know what's the secret sauce you guys have here. So you've been doing a great job. once every couple of weeks or month, I have to put them in contact to somebody who is interested in knowing, okay, what's happening here? How do you guys do this? What's happening here? So I would really like to thank you very much for the value that you've been bringing to the students, to the employers, to the community of practice here, because I think this is a great event that you have here. Yes, we will support you, of course, financially or else, but you're doing a great job, and I think this is only possible for you. So I'll leave you with that. Keep doing a great job, and we'll expect to see this getting better each and every year. No pressure.
Thanks, Mr. Hajir. Now I'd like to invite Mr. Les McMullen, Global Director of Project Controls at Hatch, to share a few words with us.
Hajir, I thought you were going to be longer. I was kind of getting ready, but anyway, thanks very much for that. So Hajir and I have known each other for ages. We've worked together. We've been on the AACEI board with many others over the years. AACEI Montreal, last year when I had a chance to talk, I gave a little history, so I'm not going to do that this year. The only thing I'll say is AACEI Montreal was the first Canadian section founded in 1961, and it has run consecutively since then. So very proud of that association. Professor Moselli here was the president a number of years back as well. And also just want to congratulate him again for his Order of Canada. That's quite a lifetime achievement. So very proud of you, Professor Moselli. That's really reflects the career that you've had and all the contributions you've made to this business. So, as mentioned, my name is Les McMullen. I'm the Global Director for the last 9 years for Hatch, which has been a lot of fun for me because I'm working with global project controls experts around the world, 7 different global regions. I've got to travel, got to see a lot of interesting projects, and work with really, really great people. Now, the construction elevator speech competition, I'm glad we didn't have to present that in a construction elevator because it would have been very uncomfortable. I have been in construction elevators and they're claustrophobic. So this is a fantastic venue. Thanks to Concordia for providing it for us. Thanks for all the Concordia students who've shown up tonight. And I want to say a special thanks to the faculty at Concordia, my colleagues at AACEI Montreal, and especially to the student committee of AACEI Montreal, who organize all of this flawlessly and just do a superb job. So I'd like to give them a big hand. Well, that was quite an evening of presentations. The 4-minute presentations, they covered almost so many elements of our business in construction management, project management, estimating, risk management, earn value, working at this site with exoskeletons, robots. It's just amazing. The future is pretty exciting. In fact, that old song, our future is so bright we have to wear shades. You guys are probably too young to remember that. That was Huey Lewis in the News, but anyway, that's what I say these days. My future is just so bright, and yours is too. So really, research. Without research, there's no innovation. Innovation is the lifeblood of companies like Hatch, the company I represent, and my other colleagues and associates that work at different companies here. It's innovation. At Hatch, we have in our manifesto, one of our values is being innovating in all we do, ensuring cost-effective, efficient project delivery. And what I saw tonight was really talking about innovation, research that could lead to innovation. So very pleased with the presentations. The 1-minute presentations were quite amazing. It was so fast, but done so well. My brain almost didn't have a chance to absorb it, and we were on to the next one. So very, very well done indeed. Another expression that we have in describing our company is we say we are entrepreneurs with a technical soul. We're not saying we're engineers with a technical soul. We're entrepreneurs. We're business people. The engineering, construction, progress management field, it's a business. And innovation is what keeps us on top and helps us provide, all of us, the services that our clients are looking for. And I was looking at a Harvard Business Review magazine on the library before we came over, and the front page, and it was from 10 years ago, but it described what many want today, our clients. It had 4 words: innovate, faster, cheaper, and smarter. And that's what they expect from us today. They expect that. And the tools and the innovations we heard about tonight, for example, can help us continue to achieve that. When we look at the innovations over the last 20, 30 years, expert systems, we talked about them in the 80s and 90s. AI, we talked about it in the 2000s. Risk management only came into play in the construction business in the 1990s. I can recall when we used to put out CVs for risk managers, we'd get people from insurance companies that the risk evaluation was how long you would live on your policy. So we had to train people in the construction business. So many things that have really come into our world over the last 30, 40 years. And I was looking for some quotes. I found one from Bill Gates on research. He says, "I believe in innovation, and the way you get innovation is you fund research and get the facts." And that's what we want to do. Innovations can come from within companies. Companies have their own projects, but also it's important to work with the universities to bridge the gap between academia and industry as such. And we've done a lot on that. And the last year, I was very happy to participate in a Zoom meeting, which is somewhere on YouTube, I think, where we talked about how to bridge that gap. We discussed the importance of connecting business and government with the universities and research, how this is being done today, but also how it can be improved. When we see discussions on robotics and productivity on site and prefabrication and recycling, certainly these are all aspects we want to include. And today we're working on the most fantastic projects to help our planet, the reduction of carbon, clean steel, clean energy. There's so many fantastic projects that we're working on, some of the biggest challenges in the world today. So certainly we want to continue to bridge that gap. And we also say AACE, with the technical knowledge and body of knowledge they have, can bridge the gap between academia as well as industry and help people prepare to come into the work world. So we want to give lots of opportunities for students like yourselves to get into the career market. There's a huge demand. A few years ago, the Construction Industry Institute did a survey, or they did trends in project controls. They talked about more sophisticated IT, and we see that with digital project delivery and digital twins and delivery hubs and all of the things that we're enjoying today. And one of the other predictions was the graying of project controls. And we see that as the baby boomers move out of the industry, there's lots of openings, lots of opportunities for all of you to get into this business. It's an exciting business. I've been in this in my whole career, and I can tell you it's exciting. If you like to travel, it'll take you around the world. You'll meet so many fantastic people, so many clients. It's just a phenomenal business to be in. So just very briefly, some of the sophistication of ET, for example, or IT, AI, project delivery hub, digital twins, 4D, 5D. I remember giving a talk 20 years ago, and I asked the audience, do you know what 4D and 5D is? Nobody knew. They knew 3D, but they didn't know that. And so we've been involved in that. Drones for measuring progress, flying over sites and measuring cut and fill, sensors to measure progress, laser scanning, managing big data, expert systems, augmented reality, digital reality. It's just phenomenal what we have. Advanced work packaging, robotics, digital twins. So it's amazing. They also talked about project complexity, and projects are getting more complex. They need experts to manage cost, schedule, scope, manage change. Well, these are all the things we do, from estimating, preparing detailed baseline schedules, and then tracking them through the life of the project. This takes skill, this takes tools, and the new tools can help us do it faster and provide that benefit to our clients. When they want to get to the market with their new product, we can generate estimates faster than ever, in integrating the 3D model with our estimating and streaming that data. So just my final minute is up. Okay. I just wanted to quote, it's a quote that I like, and I heard it years ago at an AACE meeting, and it's from Sir Isaac Newton. I don't know if you remember him, Sir Isaac Newton. He's quite famous. I think he discovered the laws of gravity or something. So no, he is really something. Law of gravity, laws of motion, and he contributed to calculus. So he was quite something. In fact, I think he was also a theologian, an author, alchemist, an astronomer, a mathematician, really an accomplished person. But what he said about what he did in life, and I really like the quote, it says, "If I have seen further than others, it is by standing upon the shoulders of giants." In other words, his colleagues, his peers, the research that he did was built on the research that had been done by others. And that's really something to remember. All my years in AACE, I've been a member since 1982, believe it or not, it's the people I've met, the giants in the industry, the people I've learned from, the people that have mentored me. And you all have that opportunity. So just remember that. Sometimes we all think we're self-made men and women, but don't forget the people that helped you along the way, the giants of industry, your professors, all the people that helped you get to that point with your research. And so some general advice in business and research, I often tell this to my teams, we need to have grit. Grit is a very important characteristic. Don't give up. Don't give up easily on your research. Keep going until you find the solution. You find something innovative that can improve all our lives in this business. And as another quote I liked, is something I've known all my life in the industry. I started pretty young in the business as a junior estimator and went through various roles as a lead cost, controls manager, vice president of project controls. And it was an interview I saw, and I said, that's exactly what I've always thought. It was ex-President Obama, and he was being asked, what advice would you give to a young person when they go out in the workplace? He thought about it and he said, you know, be seen as a person who gets things done. No matter how small it is or how big, get things done, you will be noticed. People will notice you and you will get many opportunities. So those are my closing words. Thank you so much. Much success to all of you with the vote coming up, but also in your career, in your research, and you will be noticed. So thank you all very much.
Thank you, Mr. McMullen. This is the moment you are waiting for. So it's time to announce our winners. So I'd like to invite Professor Mazdak Nikbekt to announce the winners.
Thank you, Hadi. Yeah, this is my favorite time of the year because everybody's waiting for me and I can speak forever, walk on everybody's nerve. All right, thank you very much, guys. And thanks to all of you who attended. I hope you enjoyed as much as we did. Please have your hands ready because there is a lot of clapping at this point before announcing the name of winners. By the way, the name of winners are here. So I'll leave it for now. Okay. I'm gonna set aside my notes. This was so far my favorite version of the 3-minute thesis competition. And I think I say that every year you raise the bar a bit higher and higher, and I'm not sure where we'll end up. But I seriously believe this year we had really interesting presentations, very focused and at the good level of basically development. I wanted to also explain why we had a 1-minute stream. The 1-minuters were the ones that when we were reading the abstracts, we felt they are very interesting. The only issue was they were in earlier stages of development. So we thought to have the new stream, and we're encouraging all of the 1-minuters and whoever was not selected this year to come back next year and hopefully go home with bigger prizes. I'm gonna name the superstars of the event, the students who made this happen. And please don't wait for me to finish all the names. Please keep clapping as I name the names because you have no idea how much effort and heart they put into this event. So I'm gonna start with Shruk, Azadeh. Wherever you are, can you wave so that everybody knows you? So Shruk, Azadeh, Dena, Kimia, Delaram, Abdulhadi, Araham, Amr, Muaz, and Jidobi. You are the most amazing team that one can wish for.
you are great. Thank you so much for all your efforts. And also, I want to thank again the jurors. Again, do the same, please. Do the routine. Safiato, Chris, Roxanne, and Shaheen. Okay. Now, this is the time that we ask all our requests before announcing the names. We want you guys to now take your cell phones out and scan that QR code and follow these great students on LinkedIn. This is the LinkedIn page of AACEI Montreal section for Students Committee, and it would be really heartwarming if you follow it and basically support this great team to come back the next year and the year after for even better and bigger competitions. So I give you 30 seconds to do. All right. So Sharuk, how many followers do we have now? Did we touch the 1,000? Okay. I won't keep you waiting more than this. It's time to announce the winners. We start with the 1-minuters. The third place for 1-minute presentation goes to Hosna Qura. The second place goes to Yuming Zhang. And the first place goes to Sohail Haidarian. Congrats, all three, and all 8 of you for a great job that you did. We truly enjoyed the 1-minute videos, and we know how impossible it is to talk about what you're doing day and night and only 1 minute. We're looking forward to seeing you next year in the 4-minute competition. Okay. Are we set to go for what everybody's waiting for? I'm going to start with the third place. The third place in 3-minute thesis in 2024 version goes to Mr. Shayan Shayeteh. Congratulations, Shayan. The second place goes in Bae Shung. And the Oscar goes to Rafaela Panizza. So I truly mean congratulations to all the presenters who were selected as the top 3. Usually the competition is very close, and I want to thank all the 8 and all of the people who basically sent abstract, but specifically the 8 who made it to the final round. It's not been easy to be among the top 8, and yeah, that's great. Once again, congratulations to the winners. Join me to congratulate all the 1-minuters and 4-minuters. All right, and with that, I'm inviting Professor Sama Muselhi to close tonight's event.
Thank you all very much. Thanks, really, the most important thanks is really the organizing committee. The members were already named in the early going of that session. And I would like to acknowledge and thank their mentor, Dr. Nick Batt,
Thank you very much. Thank you, members. There are 10 of them this year, and I think you've raised the bar. And I hope that next year the team will match that excellence or even top it. So thank you all very much. And thank you for members of the jury. Outstanding job. Thank you for the sponsors of this event, Hatch, AACE, and Rivian Associates. Thank you all very much. And all the audience, without you, this event would not be the event that we've seen today. Thank you all very much. See you next year.
Thanks, Ollie. It's going to be great to have a photo, a group photo, all of us, if possible. So don't go anywhere. The party is not done yet. The best part is to come yet.
Thank you so much. Thank you for coming. Really appreciate it.
محتاجين ننظم الناس ناخد الصورة فين؟ No.
Hey, thank you, everybody in Zoom for coming into this conversation, coming into this presentation, sorry. And I'm just going to say thanks to the team, of course, to help organize this. So amazing. We're going to be closing up our Zoom and our live stream now. Just let you know that this is available on our YouTube channel, that you should be watching this tonight and share it with everyone. Thanks, and see you all next year.